Unlocking the secrets of steel shot. All right, guys, Alessandro D'Amica here, and welcome to the workshop. Today, we're diving deep into a topic that's fundamental to getting incredible results in surface preparation steel shot blasting. Specifically, we're going to unravel the mysteries of choosing the steel shot size. The size of steel shot can make a world of difference to your finish, your efficiency, and even the longevity of your coatings. I get so many questions about this, and I've seen firsthand how the wrong shot can wasted material and out of expectations results. We've all been there, right? You're trying to get that perfect surface and something's just off. So we're going to break it down piece by piece, exploring all the critical factors that influence your choice, from the surface you're blasting to the equipment you're using. We'll cover anchor profiles, material types, equipment considerations, efficiency, cost, and also the specific application you're tackling. By the end of this, you'll be equipped with the knowledge to confidently select the perfect steel shot for any project that comes across your bench. So grab your safety glasses and let's get into the nitty-gritty of making surfaces submit to our will. This is going to be awesome. Getting the right grip, understanding anchor profiles. First up, let's talk about something absolutely crucial. The desired surface profile, or as we often call it, the anchor profile. Now, what is that exactly? Imagine you're trying to paint a really smooth, glossy piece of glass. The paint has nothing to grab onto, right? It'll peel or flake off super easily. An anchor profile is essentially creating a microscopic landscape of peaks and valleys on the surface of your material. This texture gives whatever coating you're applying, be it paint, powder coat, or something else, a mechanical key, something to physically lock onto. It's the foundation for a durable, long-lasting finish. And it all starts with your shot size. So how does shot size play into this? Well, it's pretty intuitive when you think about it. Larger steel shot, say an S550 or S660, acts like a tiny hammer. And because of its mass and size, it creates deeper valleys and taller peaks. This results in a much rougher surface profile, a more aggressive anchor pattern. This is exactly what you want if you're applying thick coatings like heavy-duty industrial paints or robust powder coats. These thicker coatings need a substantial profile to adhere properly and resist wear and tear. Without that deep keying, you risk adhesion failure, and nobody wants that after all the hard work of blasting. On the flip side, if you're aiming for a very smooth finish, perhaps for a delicate part, or if you're applying a very thin coating, or even just cleaning a surface for aesthetic reasons, you'll want to reach for smaller shot sizes. Think S110, S170, or S230 dot. These smaller particles create a much finer, shallower profile dot. The impacts are less aggressive, resulting in a surface that feels smoother to the touch. Using large shot on a piece destined for a thin, glossy paint job would be counterproductive. You'd see the rough profile through the paint and it wouldn't look good, so matching the shot size to the desired roughness and the subsequent coating thickness is paramount. Know your canvas matching shot to material, hardness and condition. Next, let's consider the material you're actually blasting and its current condition dot. This is a huge factor because not all materials are created equal, and you can do some serious damage if you're not careful. The general rule of thumb here is pretty straightforward. Harder surfaces can withstand and often require larger, more aggressive shot, while softer materials demand a gentler touch with smaller shot. It's like using the right grit of sandpaper. You wouldn't use 40 grit on a delicate piece of pine if you wanted a smooth finish, would you? The same logic applies here, but with much more force involved. Think about blasting hardened steel, heavy mill scale on structural beams, or tough, thick old coatings. These surfaces are resilient. To effectively remove the scale or create a suitable profile, you need shot that has enough kinetic energy to make an impact. Larger shot sizes, like S390 up to S780, carry more mass and therefore more energy per particle. This allows them to effectively fracture and remove stubborn contaminants or etch into very hard metals. If you tried to use a very fine shot on heavy mill scale, you'd be there all day, and it would barely scratch the surface, literally. It's about having enough oomph to do the job efficiently. Conversely, if you're working with softer materials like aluminum, brass, certain plastics, or even thinner gauge steels, you need to dial it back considerably. Hitting aluminum with a large aggressive shot is a recipe for disaster. You'll warp the material, peen it excessively, and potentially embed shot particles, creating more problems than you solve. For these softer substrates, smaller shot sizes, a S70, S110, S170 are your friends. They provide a cleaning action that's effective enough to remove light oxides or contaminants without causing undue stress or damage to the underlying material. The condition also matters. A heavily corroded soft material might need a slightly more aggressive, but still small shot than a lightly tarnished one. The machine matters equipment and system synergy with shot size. All right, let's talk about the unsung hero, or sometimes the villain, in our blasting equation, the equipment itself. Your blasting system, whether it's a suction feed cabinet, a direct pressure pot, or an automated wheel abrator, has a huge say in what shot sizes you can effectively and safely use. It's not just about what shot want to use, but what shot you can handle. Ignoring this can lead to clogs, poor performance, and a whole lot of frustration. I've seen people try to force too large a shot through too small a nozzle, and it's just not pretty. One of the primary considerations is your nozzle size. Nozzles are typically rated for a certain range of abrasive sizes. If you try to use a steel shot that's too large for your nozzle, you're going to get constant blockages, inconsistent flow, and you'll be spending more time clearing jams than actually blasting. Conversely, if your shot is too fine for a very large nozzle and high air pressure, you might not get the focus stream you need, and you could be wasting abrasive due to poor pattern control. Air pressure and air volume, CFM, also play a critical role. Larger shot generally requires more air pressure and volume to propel it effectively and achieve the desired impact velocity. Then there's the travel speed of your nozzle, or the part itself if you're using an automated system. This interacts directly with your chosen shot size to determine the final surface profile and cleaning rate. If you're moving too fast with a fine shot, you might not achieve sufficient coverage or the desired anchor profile depth. If you're moving too slowly with a coarse shot, you could overblast the surface, create an excessively rough profile, or even damage the part, especially on thinner materials. It's a delicate dance between the shot size, the power of your system, the nozzle configuration, and how you, the operator or the machine, moves across the surface. Everything needs to work in harmony. Now let's delve into efficiency and speed, because let's face it, in any production environment or even a busy workshop, time is money. And getting the job done effectively and quickly is key. The size of your steel shot plays a massive role here, primarily through its kinetic energy and coverage characteristics. Each tiny sphere of steel is a miniature projectile, and its ability to do work, whether that's cleaning, peening, or profiling, is directly related to the energy it carries upon impact. This is where things get really interesting from a physics standpoint, and understanding it can make you a much smarter blaster. Larger steel shot particles, due to their greater mass, carry significantly more kinetic energy, assuming they're propelled at similar velocities. This means each individual impact from a larger shot particle is more powerful. This is fantastic when you're trying to remove heavy rust, thick paint, or stubborn mill scale. The sheer force of these larger impacts can dislodge contaminants more quickly and create deeper anchor profiles with fewer passes. So, for bulk removal on tough surfaces, larger shot often translates to faster cleaning times. You're essentially hitting it harder, which can speed things up considerably. However, there's a trade-off. While larger shot hits harder, smaller shot provides significantly more impacts per unit of area for the same volume of abrasive. Think about it. You can fit many more tiny S110 shot particles into a square inch of blast pattern than you can S460 particles. This increased number of impacts means that smaller shot can be more efficient for cleaning intricate shapes, reaching into tight corners, or achieving a very uniform, consistent finish. It's like the difference between using a large, coarse brush versus a small, fine one for painting. The smaller shot excels at thorough, detailed cleaning and can often provide a more even etch, which is critical for some applications. So the most efficient shot often depends on whether you prioritize raw power or comprehensive coverage. Okay, let's talk about something that's always on our minds, the cost. Choosing the right steel shot isn't just about the technical performance, it's also about the economics of your operation. The initial purchase price of steel shot can vary, with larger, higher carbon or specially treated shots sometimes costing more per pound or per bag than their smaller or standard counterparts. This upfront cost is definitely a factor, especially if you're buying in bulk. But it's absolutely crucial to look beyond just the price tag on the bag. The true cost involves a lot more variables. One of the biggest factors influencing the overall cost is the durability and recyclability of the shot. Generally speaking, larger steel shot particles tend to be more durable. They can withstand more impacts before they fracture, wear down, or become too small to be effective. This means they can often be recycled through your blasting system more times than finer shot. Good quality steel shot is designed to be tough, and its ability to be reclaimed, cleaned, and reused significantly impacts its long-term cost effectiveness. If a shot lasts twice as long and can be recycled 10 times versus 5, that initial price difference might start to look very different. Furthermore, you need to consider consumption rates. While larger shot might last longer per particle, you might use a different volume depending on the job. Finer shot, because it breaks down faster, can sometimes lead to higher consumption rates and more frequent replenishment of your abrasive supply. There's also the wear and tear on your blasting equipment to consider. Extremely hard or large shot might cause slightly more wear on nozzles, hoses, and cabinet linings over time, though high-quality steel shot is designed to be relatively kind to equipment compared to some other abrasives. It's about finding that sweet spot where performance, longevity, and overall operational cost align for your specific needs. Finally, let's tie it all together by looking at the specific purpose of your blasting application. Are you cleaning, peening, or creating a specific profile? The end goal dictates so much about your shot selection, sometimes even more so than the material itself. Each of these applications has unique requirements, and the steel shot you choose needs to be tailored to meet those specific demands. It's not a one-size-fits-all scenario, it's about precision and purpose. This is where your understanding of all the previous factors really comes into play to make an informed decision. For general cleaning applications like removing rust, old paint, scale, or other surface contaminants, you often have a bit more flexibility, but the shot size still matters. If you're stripping multiple layers of thick paint from a robust steel structure, a medium to larger shot, say S280 to S460, will provide the aggressive action needed for efficient removal. For lighter rust or thinner coatings, a smaller shot, S170 to S230, might be sufficient and provide a smoother finish. The key is to remove the contaminants effectively without causing unnecessary damage or creating a profile that's too aggressive for the subsequent steps. Shot peening is a whole different ballgame. The primary goal here isn't cleaning or creating a rough profile. For adhesion, it's to improve the material's fatigue life and stress corrosion resistance by imparting a layer of compressive stress. For this, you typically need round, high quality, and very consistent steel shot. The size will depend on the material thickness and the required peening intensity, often specified by engineering standards. It could range from S70 for delicate springs to S550, or larger for heavy-duty components. For profiling, as we discussed in Chapter 1, the goal is explicitly to create that anchor pattern, and the size is chosen directly based on the desired roughness, mill profile, for the coating that will follow. Each application has its ideal dance partner in terms of shot size and characteristics. And there you have it. That's our deep dive into the world of steel shot sizes. It's a lot to take in, I know, but understanding these interconnected factors, the anchor profile you need, the material you're working with, the capabilities of your equipment, efficiency, cost, and the ultimate purpose of your application. It's what separates a good blasting job from a great one. It's about moving beyond just pulling the trigger and really thinking like a surface scientist, a materials expert. This knowledge is your blueprint for success. What I love about this kind of stuff, and what I hope you take away, is that there's always more to learn, always more to experiment with. Don't be afraid to, safely, try different shot sizes on test pieces, observe the results, take notes, and really get a feel for how these tiny steel spheres interact with different materials and under different conditions. That hands-on experience, combined with the foundational knowledge we've talked about today, is what truly builds mastery. It's that iterative process of trying, observing, and refining that we makers live for, right? So I encourage you to take this information, apply it to your own projects, and see the difference it makes. And hey, if you've got your own tips, tricks, or aha moments when it comes to steel shot, share them down in the comments below. I love hearing about your experiences and the amazing things you're all building and restoring. That's how we all get better, by sharing what we learn. Thanks for hanging out with me in the workshop today. Now go make something awesome and make those surfaces perfect. Until next time, keep on blasting. See you then.